we're going to continue from the previous example that I was talking about in the domain example video preceding this one. I ran out of space and I also ran out of time, I guess. So I'm going to continue here. We were talking about if we were to graph the square root function and how would we determine the domain. So the domain for our square root function we're going to say is, well, first off, the function that we're going to look at is the square root of x, hence the reason why it's called the square root function. That's what we're doing to the x variable. We're square rooting it. If we were to go ahead and plot this, note that if you refer to your class notes, we said that the values would actually start at 0, and then I pick kind of really nice, easy ones. I'm going a little bit out of order, but oh well. Because I can take, these are all examples of perfect squares, and I can take the square roots of these really easy. I don't really need a calculator. I don't have to worry about decimal approximations. They're just going to come out to be nice integer values. So in this case, the square root of 0 is 0. The square root of 4 is 2. Square root of 1 is 1, and the square root of 9 is 3. So I can go ahead and plot these points. And if you notice, I get a shape like this. And what I want to stress is that this line that you see in green is not going to level off. It's going to constantly be climbing. It's almost like it's a bridge that's never going to actually end. And it's never actually going to come back down again either. So I do want you to understand that this continues to climb upward. That's what the shape will be. Because again, if we were to continue with these points, 16 would be, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6. At no point are your y values going to come down again. They're just going to continue to climb as the x values climb. So from here, what we're going to talk about is the domain. So notice in this area that I'm going to kind of shade in orange, nothing is happening. There is no part of this function that we plotted and drew in green that exists here. So in here, the domain does not exist. This is dead space, okay? But where everything comes alive is going to be where the function exists. So that means what x values essentially did I use to create this domain? Well, it looks like I started at 0 and I'm going to continue off into infinity. So my domain, it does start at 0. I mean, this point is sitting right on the x-axis, and that's exactly where it comes into existence. If you were to drop all of these points, because again, your function here that I have in red, it's actually comprised of a bunch of points. You know, it's kind of like those famous paintings that were all stippled, so they're all just dotted with little dots of paint, and as you step away, it actually bleeds into an actual picture. This whole thing that you're seeing here, it's comprised by a bunch of little points, and as you step away, it blends itself into a solid line. So if you notice then, if I were to drop all of these little points here, they're all hitting the x-axis at this point. And it's going to continue to do so if you were to continue to draw and draw and draw. So that means that my x values will go off into infinity. This is my domain for the square root function. And you can kind of note that logically without even having to draw the image. We can look at the function f of x is equal to the square root of x, and we had discussed about this in class. Well, the smallest value that I can take a square root of, in other words, the smallest x value that I can take the square root of would be 0. And then I can take the square root of any other positive number and get a real number output back. So you can kind of either look at it using the visual, or you can kind of use it, again, using your intuition and your logic to argue that this is the domain. Okay, I hope that this little brief crash course helped. Feedback is always appreciated. And thank you very much.